Good morning, good afternoon, good evening, wherever you may be. Thank you for the opportunity given to us to present some of our research. Bread has a rich history that dates back thousands of years to early Egyptian times. Today, it is a staple and a foundation for many cultures and societies. Dietary trends come and go, and two prevalent movements are low carbohydrate and gluten-free lifestyle. Unfortunately, for many of the individuals adhering to these lifestyle choices, traditional bread doesn't qualify and provides significant limitations for them. The gluten-free bandwagon is well established and fittingly named, focuses on the absence of gluten from one's diet. Wheat, barley, and rye are the key culprits, which contain gluten and gliadin, the two proteins that when combined together with water form the viscoelastic wonder, gluten. Now, because of these amazing attributes, even though significant effort has been applied in finding substitutes for gluten, we still haven't found its equivalent. Yes, there are good or suitable products out on the market, and still compared to gluten-containing bread, well, we can just say we're not quite there yet. Low carbohydrate or ketogenic lifestyles are more recent and growing exponentially. Here, the prescriber implements a diet that reduces carbohydrate intake to around 5%, to achieve the state of metabolic ketosis, where fat becomes the primary energy source. Such an implementation has effectively demonstrated reduced blood sugar levels and decreased insulin requirements. In addition to providing immediate weight loss, ketogenic lifestyles have been incorporated as a way of managing diabetes, as well as a way to help reduce the effects of several neurological disorders. Now, I won't elaborate on these, but I will also highlight briefly that the long-term risks and health concerns of an extended ketogenic lifestyle have not been fully identified. Outweighing the benefits versus the potential risks of this extended lifestyle has resulted in some heated discussions among different groups. In addition to the gluten-free and ketogenic movements, many individuals are implementing a diet that incorporates both approaches. So finding suitable ingredients that meet both dietary restrictions can be more challenging. Our research explored several options, specifically almond, chickpea, coconut, flax, O-bran fiber, psyllium, soy, and sesame. Some of these alternative flours performed better than others, and each posed unique challenges, with adverse flavor being a key driver in several. After preliminary work, almond and O-bran fiber outperformed the others and were selected for our main study design. Again, the preliminary work was critical to our formulation development, and we found the following formulations were most effective to compare the differences between the two ingredients. 4 prototypes were created and used in our mechanical centering consumer evaluation of these bread alternatives. All ingredients were identical, with the exception to the amount of almond flour, oat-bran fiber, or the combination of both, with a formulation of 100% almond flour, 2/3 to 1/3 almond flour to oat-bran fiber ratio respectively, and a 2/3 oat-bran fiber to 1/3 almond flour, and lastly, 100% oat-bran fiber bread. Now, regardless of the formulation, all breads were close to the 5% carbohydrate range adhered in a proper ketogenic diet. Objective or mechanical testing included evaluating loaf-size volume, moisture, crumb quality, and texture using a TAXT2 texture analyzer looking specifically at firmness, cohesion, adhesion, springiness, and chewiness. And breads were evaluated at 24, 72, and 120 hours after baking. For this evaluation, 2 bread slices were combined to make a 25 millimeter thick sample for compression to 60% deformation. After initial deformation, samples rested for 5 seconds and were followed by a second compression cycle. The firmness attribute was measured by the maximum force of the first compression, where cohesiveness was the positive area of the work of the second compression divided by that of the first compression. Springiness was expressed as the ratio of the distance of the detected height during the second compression divided that of the original compression distance, and adhesiveness was measured as the negative area of compression 1. Chewiness is expressed as firmness multiplied by cohesiveness and springiness. Our subjective evaluation included quantitative descriptive analysis using a trained panel to evaluate the texture attributes of moistness, adhesion, cohesion, and chewiness, and the flavoring attributes of yeastiness, buttery, earthy, and eggy. Knowing what the typical consumer thinks was also paramount to our study, and we wanted to take a dual approach, and so recruited a group of informed panelists as well as an uninformed group. The informed group were current consumers of gluten-free and ketogenic products, and as such, they were told that they would be evaluating gluten-free and ketogenic products, whereas the uninformed group was recruited on the premises that they were just bread consumers. During their evaluation, they had no indication that they were tasting breads formulated to meet a particular lifestyle need, although after their initial evaluation, they were informed these breads were in fact gluten-free and ketogenic and asked again to rate their overall impression of the product. Here are some of the images of the breads produced through our study. Although visual distinctions are apparent after we implemented the objective testing, significant differences were observed. The bread made with 100% almond flour produced significantly larger loaves than the two hybrids, which were both larger than the bread made with 100% oat bran fiber. Additionally, cell density and size uniformity were more consistent with the bread containing higher amounts of almond flour, and they had a more rounded distribution, and the majority of the gas or air cells fell into the 1 to 7 millimeter square range. Conversely, cells were smaller and more numerous with the higher amounts of oat bran fiber. With larger amounts of oat bran fiber, there were fewer gas cells larger than 7 millimeters squared. However, although fewer in percentages, those cells that were in that range were significantly larger and usually exceeded 15 millimeters squared. As I show the previous image again, the bread and crumb structure, it's more apparent that the oat bran almond hybrids and the 100% oat bran fiber bread do have smaller and more numerous cells, and those cells in the higher cell size range are significantly larger than the bread in the almond flour variations. Now, large tables with numbers and letters all over the place can be confusing, at least for me at an initial glance, so allow me to highlight a few points. Looking at statistical significance, the capital letters refer to differences in the same row, contrasting bread variations, while the lowercase letters are used to highlight the differences in the various time points. Within the same treatment. Sorry, my slides advanced when I wasn't ready. Now, I won't address all the attributes, but I will emphasize a few that stood out. There was a significant difference in the firmness of the treatment models, with the level of almond flour correlating with a less firm or more tender product. And as the levels of oat bran fiber increased, so did the firmness of the bread. What was unusual was that with the exception of the 100% oat bran fiber bread, all other treatments decreased in firmness over time. We're still investigating why that occurred. We have several hypotheses. That will be for a future publication, hopefully. Springiness actually showed no statistical differences between treatment or time. As springiness is related to scaling, this actually wasn't as surprising, as scaling occurs during the retrogradation of the starches or amylose and amylopectin. And since our formulations were very low in these carbohydrate sources, we didn't expect to see much, if any, scaling, as supported by the data shown here. Now, contrary to the mechanical testing, in which the oat bran fiber was moister than the almond flour, the Century panel actually perceived the almond flour product as being moister. This difference can be attributed to the ability of oat bran fiber to bind more water than almond flour, and because of the coarser texture of the oat bran fiber, which is suspected to have contributed to the differences in perceived moisture scores. Higher amounts of almond flour also correlated with higher scores in the buttery and eggy flavor notes, and higher levels of oat bran fiber contributed significantly to the earthy notes. Now, looking at the results from the consumer acceptance studies, almond flour and the almond oat bran fiber hybrid were preferred over the oat bran fiber almond and the 100% oat bran fiber breads. Although consumers approved of all the breads, they were less likely to purchase the 100% oat bran fiber bread. General consumers also identified the almond flour bread having better flavor and texture with the oat bran fiber bread being less appealing due to the higher earthy notes. In summary, almond flour and oat bran fiber are suitable ingredients for ketogenic gluten-free breads. Almond flour resulted in a structure and a texture that was superior and preferred to variations higher in levels of oat bran fiber. There's some additional work we'd like to explore, especially looking at correlating the differences between several of the subjective and objective endpoints, which always didn't match up, and that will be some future research that we conduct. Thank you for your time, and I'd like to open it up to any questions. As well, invite you, if you have additional questions that you'd like to ask, please email me at gene_ahlborn@byu.edu, or if you would like to discuss potential collaborations, please send me an email. Thank you.